Perfect. So we are going to clean this guy up today. One thing I definitely wanted to do some more work on was making it look a little less, you know, awful, just in general. So, um, really quickly and easily, what we could do is just open this guy up and fix some of these features. So, big thing I was looking at or interested in doing was extending this fillet out to have some additional features. Like you could pretty easily just like round these guys out. Um, you as well. You too. It's probably not going to take to all of these. We'll see. Let's see what happens. And nothing. Doesn't work very well. So how about instead of editing that feature, we just make this 0, make it a little bit bigger. Cool. Then we can add, let's hide that sketch real quick. What are you part of? Cool. I'd like to really round these out a little bit more. So let's fillet you and you, and let's drop this down to 0.05. Let's just let's see how that looks. Okay. See what that looks like. Common corner faces. Okay. So is it this thing that you have a problem with? Probably these guys. I had to guess. Oh, we don't want that face. And this. Cool. Let's see if that works. Does not. Ah, turns out it highlights it. Ah, what happens if we do that? Does not like it. Is that not about you? Okay. Seems really picky. Well, scratch that. We're not doing that right now. Um, Maybe we can edit that geometry with our actual sketches. So those features were cut out here. Let's edit this sketch a bit. Yeah, and we can go fill it right in here. Between those two, spread out a bit. We'll add those, trim away. Oh, we don't have to trim anything. Kind of like that. But also like, I think I'm gonna do away with this geometry here. I think I'm going to kind of you two are going to be tangent, and you two are going to be tangent. Cool. And then we're going to do something like that. So we actually want these to be tangent as well. So I'm trying to smooth this thing out here. So then we'll drag our line. We'll trim this guy away. Trim you, trim you, trim you. And then these are symmetric right now about that. Get rid of this coincident. And we'll just drag these two. Actually, we can probably just say that these two are tangent. Uh, oh, that's not good. So this and the origin need to be vertical. Cool, now we have an enclosed thing here. Actually lied, I don't want this to be tangent there because I want to pull this away from this edge a little bit. They're no longer coincident. This thing is also going to be vertical with the origin. You know what? Why are we complicating things here? Just get rid of those and make this one line. And we can say that these two are going to be, sure, 0.45. Now if we go through sketch here, we have show me where the problems are. How much of this are we gonna have to redo now? I feel like a lot of it. That wasn't the issue. There we go. So there's just something weird in there somewhere. So these two are equal. And let's set this radius again, or this distance here to 0.45. Oh, that's not what we want. We also want these guys to be equal. That's not what we want. We also want, let's back it up right here. So these two are going to be horizontal from each other. So that should lock that in. You guys, I guess I could actually make this really easy and do center line here. So I can say everything is symmetric about this. So you guys are all symmetric. Symmetric. You guys are all symmetric. And well, so now what is this mad at? We also need to make these lines collinear with these. So let's go collinear. That's all locked in. Cool, cool, cool. These actually can probably just get deleted. They don't even matter anymore. And this thing, we can just make this pretty easy actually by just saying that these are tangent. Cool. And it's still mad about distance. And we decided on 0.45. And it looks like it's not enclosed. So let's see what the issue is. Well, I guess we have to go through this again. What if we make our lives easy and what is this? Oh, you're not color this linear, and you guys are horizontal. Happy, happy. This is going to be tangent to this, and here. Oops. This guy. You guys are going to be tangent. And then you're also going to be touching that thing. Cool. And trim these away. And we'll set circle here and make these tangent. Just before we forget, we'll make this thing collinear and smart dimension this 0.5. And you two should be coincident. And how crazy would it be if we made these two equal? Does it break everything? Not at all. Perfect. Cool. So now we say mirror. We mirror you guys about, whoa. Mirror you guys about here. Wow, that took way too much work. We don't care. We do care. I wonder why this is still mad. What are you mad about? What are you mad about? If you shrink this down a bit. Oh, no, a little bit bigger than that. Um, this is mad. Multiple disjoint closed or single open. Where though? Doesn't help me at all if it doesn't say where. This thing is freaking out. Okay. Do we even care? Do we even care to round these things out? It's hard to know. Okay, I think I'm going to brighten this guy up a little bit. Let's go with filters. New color correction. We're gonna brighten you up. Sure. How bad does that look? Let's see. Tempted to just do something crazy like this. And then make these guys and this guy coincident. And we drag this up. You enclosed now. What happens if we do this? Really doesn't make any sense. Okay. All this is a waste of time, I guess. Let's just go back to our straight line approach. If you touch here, we'll come up like this. Maybe we'll just do this. if it was just the fact that these were not enclosed somewhere. We're just going to be extra careful here. See if that does anything. Do I have anything? Okay, we're just not going to save this. We're going to reopen it. So I still don't fully understand what's happening. So instead of dealing with that headache, what I'll do instead is be lazy and sketch on here and trim away the extra stuff that I don't want to deal with. So we'll do the same thing we were doing before. So a rectangle in from like here to here. Um, and then we're actually going to trim away this guy and put some lines in. Vertical. You're going to be you, and you are going to be collinear. And we can do this now. We will actually get rid of this and do what we were attempting to do before. So again, I think the easiest way to do that is to make all of these on the sketch here, horizontal. Same thing. I actually don't care about this dimension at all because there's nothing on his face that's going to interfere with. So I'll kind of just leave it for the time being. And then we're gonna, oh, that's too big. Let's do 0.1. Get rid of this line. Maybe 0.2. Maybe 0.3. Sure. And then we should be able to now we should be able to shoot cut and get rid of all the garbage that I want to get rid of initially. Cool. And we'll flip the direction and we'll go up to vertex. Pick that guy. That's cool. So that rounds that out nicely. Um, and I wonder now if we can just throw the fillet that we want to throw on before. What does that look like? Cool. I actually might increase that um, size a bit, and we'll select some other contours here. See if it gets mad at us now. Make that 0.1. Is it mad? It's mad. Okay, so we won't select these edges. Then we'll see what happens. It's really upset about what feature is it mad about? Okay, whatever. That can be a flat face. Not super worried. Um, I'll grab this guy too. Cool. Cool, cool, cool. Okay, I'm not mad at that. So that's cleaned up a bit. Um, one thing I was thinking is that I am not sure how I feel about um, this being like a. So the idea is that the nose rest of the mask of the MetaQuest 3 will grab onto the surface here. So I don't know how I feel about that just being kind of like a friction hold, because the second I bump that or shake my desk for whatever reason, it could fall off possibly. So unfortunately, I don't have my Quest with me, but we'll kind of mock up some solutions to that. Um, I actually think that if this is dimensioned correctly and the strap for the headband is set at the right length, this should kind of, I'm hoping, provide enough force, friction force or downward force on the mask to kind of friction hold this in place. But again, maybe we don't want to rely on just that. So I know the mask is this wide. This is my reference line for the size of the mask. Um, so what I'll probably end up doing is making some little tabs here, almost like little detents that grab the side of the mask. Um, or maybe we say we don't even care and we double check that our screw geometry looks good, and then we'll test print things. You know what? I like test printing things. So let's go to our assembly. We'll rebuild our assembly. So we clean that up a little bit. Everything looks a little bit nicer. I'm still kind of happy with how this foot and clamp design works. Realistically, I could. Um, oh, you know what? That reminds me. I actually did have something else I want to change about this. I want to taper these a bit. So those little arms there, I believe, should be tapered because I don't want this when I mount the controllers inside this arm. I kind of want it to guide in nicely, and I don't want to have to like press the button down as I press the thing in. I want this to be tapered so the button on the controller presses as I insert it into this slot. So what we'll do is what angle do we want this to be tapered at? So what we can do, I think, is just make a vertical line, and you are going to be vertical, cool. And then we'll have an angle that's guided off of this. Um, Smart to mention this thing at an angle of, let's say, like a 5-degree taper. Nothing crazy. And if everything is designed correctly, I have all these set as vertical right now. So I should be able to get rid of all the verticals and tangents. Actually, we keep the tangents. We'll get rid of all the verticals. Oops, not the line, the verticals. So these lines should no longer be vertical. And what I can say now is that if I throw a center line in here, um, this thing should, oh no, we don't want to do that. So let's dimension this off of the origin. Works for me. So that's dimensioned off the origin. Um, let's let's say that tangent, tangent. It's this intersection. Oh, that is intersection's gotta go. Now I should be able to say that this is symmetric. Is there a way to add a relation to? Oh, that's how I want this endpoint and that endpoint to be symmetric about that line. Cool. So now we have our 5-degree taper. And if all goes well, I'll probably have to delete this dimension and uh, make sure I'll just define this. Um, and what happens if I say that these are parallel? Everything breaks. Uh, cool. So something's over constrained here. We'll delete that. Um, cool. Kind of delete that for now. Uh, now you should be tangent to this. What is tangent? And this guy. Cool. Um, so now I can probably go here and say parallel. And this is also going to be parallel. What are you parallel to? Why are you not parallel to you? Why are you mad at that? What relation does this have? Or are these symmetric? Cool. Now we know that this thing can't be tangent with that if we want this to look right. So U3, can I select 3 at once? I can. Parallel. Cool. So I'm kind of happy with how that looks. It's a jumbled mess right now with relations. So, I guess just for some background, some rationale behind why I do everything the way that I do. It is because, um, as a wee young engineer, mechanical engineer back in the day when I was doing my first internship and job doing mechanical design, I would never drive anything based on relations. I would always dimension everything. So what I think the intuition that you develop by setting everything to be dependent on relations to each other, like tangent or equal to or symmetric about, you develop a lot better design intuition. So you don't need to be super explicit with how you define things, so you can be more rapid and say, oh, if all these things are related properly, now I can set up a system where I can really quickly make modifications to one portion of my design, and I don't break everything else in my design. The worst thing to do is to design a full assembly like this guy here, and then go into one of your parts, and if everything is explicitly defined and not related to all your other drawings or sketches, if you change one thing, it could break several things down the line, which is kind of what you saw when I was trying to fill at this edge here. You want everything to be related correctly. So now that all this is related nicely, I can just change this value and everything updates accordingly. So I can, in real time, look at this and say, oh, I kind of like, not what I want to do. I could say, oh, I kind of like what 3 degrees looks like, which is true. I do kind of like how 3 degrees looks. And this distance here, while it's not defined, um, I think we can kind of guesstimate and say that it's 3 inches. That's probably even a little too much. So let's say 2.5. Um, I lied. We're gonna do 3, because why not? Cool. So, we broke a fillet, as I had mentioned before, that we do all this so we don't break fillets, uh, or other features, and we broke the sketch. So this fillet is probably dependent on a face that we just changed. Um, so if I edit this, it's gonna tell me, ideally, what it doesn't like. And I think it's because let's try reducing the fillet size and see if that unbreaks it for the time being. All right. Instead of really trying to unbreak this thing, we could just maybe we can pull it down, can't reorder. So what is broken? Let's try deleting some of these, not those. Let's try deleting just incrementally delete faces or delete edges until this is happy. Let's see if this is causing it. Bingo. So why are you mad now? Oh, okay. So instead of the edge, we'll select these faces. Works for me. And then grab you, you, grab you, and we'll grab you. I believe that was everything we had done before. Nope, we missed this. Sweet. So now we're kind of where we left off, and I'm a little happier with that. So actually, what may end up happening, again, because I don't have the quest with me to kind of grab these dimensions, but maybe because of this line, I actually think the quest is just about like 7.25 inches long or wide, if I remember correctly. What may happen now is these little tabs here, these little um, fingers that are meant to grab the controller may also work to kind of compress against the sides of the quest and retain it. So you kind of snap the whole thing in place. So again, we won't really know till we print this thing, but um, kind of happy with how that looks. And let's see, we can might as well select a material on this guy because we know it's going to be PLA. Um, do they have PLA? They do not have PLA. So I only care about this for an aesthetic reason. So let's just select a similar looking plastic, which normally in Nylon 101 is pretty similar looking. And we'll adjust the appearance. Just the appearance of, I think this whole face we should be able to do. What do they have here? Texture? Ooh, I kind of like these. something like that. Okay, actually, so instead of just doing that face, should be able to go here and edit appearance. Ooh, now we have a nice, pretty, kind of gloss black representative view of our bracket. Save that, go back to assembly, um, and modify the appearance of these things. So I should be able to go copy appearance and paste appearance. Maybe not. Paste appearance. Ah, there we go. Bingo. So this is actually what this will look like. Pretty close. So now that that's a little bit cleaned up, what other things can we add? Um, I really should take another look at. Let's see, right clean. Let's do a section view of this. And select. Oh, our position got all mixed up. Okay. What mates do we break? Concentric. So we know what we can do actually, to ensure that our screw is properly centered relative to our threads, just to do kind of like a visual uh, check on whether or not our threads will mesh correctly, as we can say that this guy and this guy are parallel. So unfortunately in our model we won't be able to move that around anymore, but I just want to check to make sure that our threads kind of mesh up well, because we did design these threads ourselves. So they're probably awful. That's the gist of it. Let's flip you around. I want to see whatever. Let's zoom in here. So, yes, one thing I did want to do, because that's line to line right now, that's a big problem. And I think that's what's causing that. Yeah, that's what it is. It's because it's line to line. So, that's an issue. And I'm glad I remembered that we did it that way, because that's stupid. So what we can do in our bracket here is we had this hole cut, which I think we can just pop in here and say, well, come on, instead of being a half inch, you're gonna be you're going to be um 0.51. So now this is 10 thou wider than the shaft of the major diameter of our screw thread. Major diameter is, let me just features, let me, where's my rebuild button? Rebuild and save the document. Okay. If we go on our assembly, I can show you what I'm talking about. So before, how this was set up was that the maximum diameter of this thread, the edge of this profile, was the same diameter as um, the smallest, or I guess the same diameter as the mating surface of the receiving side of the threads. So that means that because nothing is made completely perfect, even if it was, you're going to be having those two faces ride against each other as you drive these screws into place. Again, 3D printed, we want to keep like 5 thou tolerance minimum, especially with the kind of 3D printing I'm using. There's SLS 3D printing that's a little bit more precise, but I'm just using an extrusion based, I believe it's FDM 3D printer. So that's just a little nozzle with some hot plastic coming out the tip of the nozzle, and it goes around and traces the path of the print. So I actually left a 10 thou gap here, um, and what I actually want to do now, since I increased that gap, is figure out if I'm actually okay with having these radii be different. I think what I want to do is make the radius the same, because the everything is driven off of everything in the bracket for this thread is driven off this the diameter of the first extrusion. So I may be able to go in here and say that this sweep here, let me edit the sketch wherever the hell it went. Yeah. Okay, let me normal to, what face is this? Where's my, yeah, there we go. So now we can say that this radius, because we made it a little bit smaller before, I believe it's, was it 2.5? Let's just double check. Let's just double check. I want to open this part. Okay. Oh, 0.03, 0.027. Okay. So if that's 0.027, I'm actually pretty confident we can make this 0.027 as well. And hold on a second. You need to be a whole lot bigger. And as do you. 0.027. 0.012. So that's going to be 0.02. So this is all kinds of screwed up. Whoa. Yeah, we need this to be 0.027, not 0.27. Fix that. Why did that not update? To 7. Cool. So now I'm pretty confident that if we go back in here, you just make sure that these guys are saved. Now if we go back into this assembly and we go back to our section view. Something looks a little funky there. I think we need to increase that line length. So that's something that we have dictated on the bracket that is not dictated on our screw. Do we have this 0.0274? How bad is it if we just copy paste? Okay. So this should be the exact same profile, just kind of grown out a little bit. So I'm hoping, let me just save this. We go back into our assembly. Let's rebuild the assembly now and go back to our section view. What does this look like? Much better. So I'm pretty happy with that. And just as a verification, um, maybe you can't see the normal distance between those two is 5 thou. So I'm gonna grow that a bit. I want it to be a little bit bigger than 5 thou normal distance. So this bracket, go back to this sweep. Actually, it's in this guy here. Let's make this 0.51 5. Let's see what that does. And we have to save, rebuild. Where did my bracket go? Okay, let's make sure we didn't screw anything up too bad. Normal distance is now should be 75 thou, or sorry, 7.5 thou, not 8 thou. So 7.5 thou, I think I'm pretty okay with. Again, we'll have to 3D print this and see how it actually works, fits together, because typically we look at like 5 thou or slightly worse for a tolerance on 3D prints. But these are threads and they're pretty complex geometry. So unless I find a good way to print this with doing something like a support and printing it on its side, if this just prints from the knob up, that tolerance might be actually a little worse, because you're gonna that printer is gonna come along the profile here, because it does like cross sections, right? So as we're printing, the 3D printer is going to come along this surface here and add material, one layer of material to like this cross section, and just do that until you get your full part. So this is layer, 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 and it can actually kind of build material laterally without any material underneath it, because the plastic that was just extruded should actually be set and no longer in a malleable state. And then you can kind of take the extruder, the head, and come off at like an angle to start growing out and grow a profile. So that's something that the printer can do. I don't know how well it will do in this format specifically. So we may have to do something like print this thing on its side and then have the threads print along this cross section here. Let's see. Yeah, so this would be the cross section of the part as it's printing. So as you can see, it's a lot bigger, and you can add material as a support underneath the bottom of it. So it'll print on support when it starts to make those threads. So we'll see. We'll experiment. Support material will probably make it a little bit, the thread's a little sticky, meaning there's going to be some leftover little pieces from the support material that I'll either have to file down or just wear in by using this thread repeatedly. So I think I'm pretty happy. I think I made the improvements. I verified the things I want to verify with this. And until we actually print this and test it, there's no way to know if this is going to be successful. So what we'll probably do is wait until I have a tested demo, or a printed demo of this, and see if it works. And then once you have it in your hands, you can figure out how you want to improve it from there. So kind of thinking that will be the design, the next step. And this is actually exactly how design process works in the real engineering world. You design something that you think will work. You got to get some real, actual physical pieces in your hands, try to build it, see how it works. I'm actually a manufacturing engineer, so building it is my forte. And then I'm not going to be building a bunch of these at scale, so I only need one of these for my application to work. If I start selling this, yeah, I want to refine the design so that I can make these in larger volumes and not have to deal with individually like sanding down different components. So, or like this ball joint here, I'd change that from two separate pieces to one with support in between, and then in order to get that ball joint to articulate, I just snap the support so it's one piece. Kind of optimizes that process so I don't have to manually install it. So those are kind of things that go on in the design and manufacturing engineering world. So that's where we'll start off next time around. But I'm pretty happy with that. I'll run a test print and then we can check in with how it's doing and go from there. All right, I'll see y'all later.